All right, so now we know the steps to evaluating different acids qualitatively. So let's try it. And what we're going to look at is the first effect, the element effect. So, what element is the acidic proton attached to? So, to look at this, let's look at a couple of molecules that could be acids. So, the first one we'll look at is water, so H2O. The second one that we will look at is ammonia, so NH3. So NH3 here. So now it has three H's, and we're going to react these with just a generic base. So I'm just going to write B minus with some electrons, and we'll draw in the lone pairs on these two molecules as well. So what we're asking ourselves is, which is more acidic, water or ammonia? And if we follow the steps that we learned in the last video, what do we have to do? We have to draw the conjugate bases, so what would be on the other side of these arrows, and determine which of those two is more stable. So in looking at these acid-base equations, the base is going to deprotonate the acid. So on this side of the arrow, we would have OH minus plus BH. And down here, the base would deprotonate the ammonia to make NH2 minus plus BH. Now we have our conjugate bases. So this is a conjugate base, this is a conjugate base, and we have to ask ourselves which of these is more stable. Usually when we're talking about stability, the molecules have some type of charge on them, and what we have to evaluate is which of the molecules is more stable with the charge that it is holding. And both of our conjugate bases here have a negative charge, negative formal charge, -1. So we have to ask ourselves, is oxygen more stable, is it more happy having a negative charge, or is nitrogen more stable, more happy having a negative charge? So here we would want to go to our periodic table, and here's an abbreviated one that we'll use in this instance. And what we see here is that we're talking about atoms being stable although they have a charge, and it's a negative charge. So what periodic trend would speak to that, and that's electronegativity. So if we look at nitrogen versus oxygen, they're right next to each other in the periodic table, and we know that the most electronegative atoms are in this area over here. Least electronegative would be down here. So oxygen is more electronegative than nitrogen. So because oxygen is more electronegative than nitrogen, it is more stable. So it is more stable. So because it is more stable, the third point of how do we qualitatively compare acid strength is the more stable conjugate base came from the more acidic acid. So OH minus is more stable so H2O is a stronger acid. Okay, and we can take this a little bit farther, or further. So if we have acids in the same row, the same period of the periodic table, we can use this periodic trend of electronegativity to compare the acid strength. So if we compare carbon versus nitrogen versus oxygen versus fluorine, we have different types of acids. So carbon might be attached to 4 things and have a hydrogen. Nitrogen is going to be attached to 3 things, and one of those is going to be hydrogen. Water or oxygen would be attached to 1 thing, and fluorine will have its hydrogen. So we already said Oxygen, because it's more electronegative than nitrogen, is more acidic, but fluorine is more electronegative than oxygen, so it would also be more acidic. So as the electronegativity increases, so increasing electronegativity, increasing acidity. So FH is more acidic than OH, than NH, than CH. And I have to note that this is also only if they're the same charge, so these are all neutral molecules. And three of the pKa values that you had that you were supposed to memorize are this, and this. But an aliphatic CH would have a pKa of around 50. An aliphat or an NH neutral would have a pKa of around 38. Water or an alcohol would have a pKa around 16. And one that you were not supposed to have to memorize, FH, has a pKa of 3.2. So you can see that while these atoms become more electronegative, they're becoming stronger acids as well. So that is the element effect, the first of the four effects that we're going to be talking about, and that's the element effect going across a row or a period. So next we'll discuss the element effect going down a group.